Okay, starting the recording. Um, First of all, a couple of announcements. Next week is vacation. Yay, we get a week off. Okay, so next week, and I don't have 25th-ish, okay, is not week 13. I'm hoping to publish week 13 at the end of this week. You are welcome to start over vacation and work ahead because the end of the year is coming really quickly. But next week we'll have no mandatory work. Okay. So if you see like, oh my gosh, she doesn't know it's vacation and she published the next module, that's just in case you want to work ahead. Okay. No, sorry, 12. Next week is 12. This is 11. Next week is 12. I'm hoping to publish it by the end of the week. Okay. So our exams have been week 4, 8, and the next exam is not week 12. Okay. So it's just a little too crowded at the end of the year. I am pushing the next exam to week 13. Okay. So it's the next one is week 13. So next week when we get back, we are doing the practice exam this week, but the next exam will be week 13. And that's horrible. Sorry. Next exam will be week 13. And then there will not be an exam like week 16 and then final week 17. It's just too difficult to do. So week 13 will be the next exam. The week 16 exam material will go on to the final exam instead of having two. That was just too crazy. Yeah. Okay, so let's get started. Now we are done with those rational equations and expressions. Do I hear a yay? Those are the ones with like solve and you have to factor and all this stuff. We are starting trigonometry. Okay, yay, I like trig. And if you remember, you started trig last year in geometry. So hopefully you remember the trig you learned, hopefully the basic trig. We're gonna do number 7 first. Now in geometry, you learn that if two triangles, okay, so we have the red one and we have the pink one. If two triangles have congruent angles, okay, we call it angle similarity. So look, the red one and the pink one share that angle right there. Okay, and we know that this is a right angle and they're both, sorry, I switched colors. So they both have one angle that's 30, another angle that's 90. By angle similarity, we know that the triangles are similar. And if the triangles are similar, corresponding sides are in proportion. And you're thinking, oh no, don't remember what in proportion means. Okay, everyone remember what in proportion means? Same ratio. Okay, that means they have the same ratio. Awesome. They reduce down to the same ratio. Not ration, ratio. Okay, that means they reduce down. Okay, now 30, 60, 90 triangle. So hopefully you talked about this last year. If I flip it down, does everyone see that this is 60? Yeah. And what would this full angle right there be? 30 and 30, right? So 60. Okay, does everybody see that this would be an equilateral triangle? Okay. So let's make let's make this side 10. Okay. Then this is 10. This whole thing is 10. Now, what would this side right here be? Yeah. Yeah, Zoomers, what do you think? Okay. I'm going to make this go away now. If this is 30 and this is 60, and this used to be 10, I flipped it down to double. How much is that right there? That is half. Yeah, Zoomers, do we see that it's 5? Okay. Now, if I were to do Pythagorean theorem to solve for x, do we remember Pythagorean theorem? Yay. A squared plus B squared is C squared. Okay, not shushing you, that would be the symbols with my drum. Okay, so let's do Pythagorean theorem. X squared plus 5 squared. Pythagorean theorem, the hypotenuse always has to go alone on the other side. Okay, x squared plus 25 is equal to 100. Subtract 25, x squared is equal to 75. And what's the last step of solving for x? Okay, so the opposite of squaring is square root. Okay, square root and square cancel. Now, square root of 75. What is, I need the biggest perfect square and the leftovers. So we have 25 times 3. Square root of 25 is 5 square root 3. Okay, if you're just now writing that down, take a picture because it's about to disappear. Okay, so we have a 30, 60, 90 triangle. 5 square root 3 and 10. Excuse me. Okay, so 30, 60, 90 is known as a special right triangle. And it all comes from the fact that we took an equilateral triangle and cut it in half. And that's going to help you remember the formula. Okay, so now if triangles are similar, corresponding sides are in proportion. So what if I make, okay, one more thing. This is called the short leg. So all the short legs are going to be in proportion. This is called, what do we call this one right here? Hypotenuse. And this is called the long leg. Okay. So now if short leg to short leg is 5 to 6, yeah? So now if the short leg is 6, does anyone want to guess what the hypotenuse is going to be? Ding, ding, ding. Can we see that if the short leg to short leg is 5 to 6, hypotenuse is going to be 10 to 12, right? Okay, now, what about long leg to long leg? Okay, if the sides are proportional, if the side of this one is 5 rad 3, the side of the bigger one to be proportional with that is going to be, oh, no. What else do you want to guess? Okay, I'm glad you're here because, okay, so if these sides are 5 to 6, that would be the short. Okay, the long is going to be 5 rad 3 to, anyone have a guess? 6 rad 3. You just take the short leg and you put it right there. Okay. Let's do a question.
The long leg is always like the short leg multiplied by that.
Yes. Okay, so let's just do this one, but I'm going to draw it. Okay, so I'm going to draw it right here. What if this is 7? What is the hypotenuse going to be? Yeah, Zoomers, what do you think? If the short leg is 7, the hypotenuse is 14, right? Okay. And what is the long leg going to be? 7 rad 3, because they all are in proportion. Yeah, let's look back at this one. I could cancel radical with radical, and that shows me I get down to the short leg to short leg is your base. You always start from there. Okay, let's practice. What happened? Okay. Okay, so now I have the long leg. So remember, this was, we're going to call it X, 2X, and X rad 3. Yeah, what we just had was we had 5, 10, and 5 rad 3. Okay. So this is 60, this is 90, this is 30. First of all, what do I call that one? Short leg, long leg, or hypotenuse? Long leg. Okay. And which one of these is the long leg? Okay. So right there, right? X rad 3 is equal to 9 rad 3. Yeah, Zoomers, does everyone see that? I match up corresponding parts, long leg with long leg. Now we need to solve this equation. Okay, in order to isolate the variable, what is my next step? Yeah, does everyone see that it's divide? Sometimes you want to think, oh, can I square both sides? No, don't square both sides. You only square both sides when the radical's on the X, right? So I'm not squaring both sides. I am dividing by rad 3. Okay, so X equals 9. Now, the more you practice these, the quicker they're going to get. The long leg is 9 rad 3. The short leg is 9. And we can see that I went from 9 to 9 rad 3. Another way to think of it is short leg to long leg multiply by rad 3. But what if I go backwards? What if I go long leg to short leg? I would divide by rad 3. Okay, we always find the short leg. That's always the first thing we're going to find. Okay, so now we're going short leg to hypotenuse. When the short leg is 9, the hypotenuse is, yeah, we're going to multiply by what, Zoomers? Short leg to hypotenuse, we're going to multiply by 2. So this is 18. So what is our strategy? Always find the short leg first and then go by this rule. Okay, number 2. First of all, then, oh, you guys, do we mind if we change it? I don't want that to be 9. Let's have that be 8. Okay, so first of all, what have I found? I've found, or I've given the short leg. Okay, so okay, how do I go from short leg? I always like the hypotenuse better than the long leg. Short leg to hypotenuse. Multiply by 2 equals 16. Short leg to long leg. Okay, Zoomers, everyone give me the value of the long leg. How would I type in radical 3? You would go V3. Okay, you could also, sometimes in the Canvas quizzes, it's SQT, just because it started off SQT. So Zoomers, thank you. 8, rad 3. Okay, we are going to come back to number 3 later, or you could do that on your own. Now, that's not a 30, 60, 90. Okay, 90 plus 45 is 130. That leaves 45 over here. Okay, 45, 45. Now, think back to your geometry. What do we call a triangle with 2 congruent sides? Equilateral is 3 congruent sides. 2, this is the hardest. This is the hardest to remember. Isosceles. Okay, this is an isosceles triangle. Okay, if 2 base angles are congruent, then opposite sides are congruent. Yeah, so I could call this A and this A. They're going to be equal to each other. So let's use Pythagorean theorem. A squared plus A squared equals 5 rad 2 squared. Okay, hold on. I don't know how to do this. 5 rad 2 squared. Okay, the first thing I'm going to do is I'm going to write it twice. And I'm going to multiply outside with outside, inside with inside. But this is a perfect square. So square root of 4 is 2. So as you do this, you're gonna get faster, and you're gonna go 25 times 2 is 50. So I'm gonna say 2a squared is equal to 50. Next step, divide by 2. So a squared is equal to 25. Last step. Okay, yay, 25 is a perfect square. So a is equal to 5. Technically, it's equal to plus or minus 5, but you're not going to have a negative number the side of a triangle. So X is 5. And how do we find Y? Okay, isosceles, it's the same length. So also 5. Okay, so if I had another isosceles triangle, so I'm going to get rid of this. Actually, I'm going to get rid of it just in case someone has a question. Okay, shoot. Okay, having a hard time. Okay, so we have 5, 5, and 5 red 2. Now we know that if two angles of one triangle are congruent to two angles of the other, the triangles are similar and the sides are in proportion. If this is 6 and this is 6, and they're all in proportion, then what do you think the hypotenuse is? Six rad 2. What if this is 45, 45, 9 and 9? Okay. So 45, 45. If this is X, okay, Zoomers, if it's 45, 45 and the left side is X, the right side is also X. And the hypotenuse is, look at our pattern. Notice if angles are congruent, triangles are similar, sides are in proportion. This side is X rad 2. So this is like our parent triangle. Okay. Number 5. Let's draw our parent triangle. X, X, and X rad. Now, if this is 45, 45, is it rad 2 or rad 3? 2. Okay, what are we going to do next? Okay, we need to find A and B. Let's match this one up with our parent triangle. So 2 is going to match up with, yeah, see, hypotenuse, hypotenuse, corresponding sides. So X rad 2 is equal to 2. Okay, how do I solve for X? Kind of a bummer. Oh, divide by what? Nope. Okay, divide by rad 2. Ah, such a bummer. No radicals in the basement. Okay, I can't leave it this way. Never leave a radical in the basement. But I know what to do if I ever get a radical in the, you didn't see that. Okay, if I ever get a radical in the basement, I'm multiplying by a form of 1. If you multiply by 1, you don't change the value. Okay, so what goes in the box? Okay, so whatever the denominator is, so 2 over 2, that's a form of 1. So I have 2 rad 2, and rad 2 times rad 2 is rad 4, which simplifies to 2. Whoa, I don't even know. Can I cancel? I see a whole bunch of 2s and I would like to cancel, but you need to be very careful which ones can cancel. So you can only cancel outside numbers with outside numbers, right? You can't do an outside with an inside. Do you see what I mean by outside? Reals with reals, radicals with radicals. Okay, so those cancel. So x is equal to rad 2. Okay, so this one was weird. The hypotenuse did not have a radical, but the leg did. And what do I know about the two sides of a 45, 45, 90 triangle? They're the same. So B is rad 2. Okay, so we have two things going on. We have the parent for the 45, 45, 90 triangle, and we have the parent for the 30, 60, 90 triangle. Let's label this. The small one is 30, 60, and 90. So you're going to use your parent triangles, and then you're going to write equations and solve. Okay, you're going to do number 3 on your own, or we're going to do it together. Okay, once again, I'm going to change this. That's boring. Let's change it to 7. Okay, 45, 45. How do I know that? The sum of the angles of a triangle is 180. Okay, B is also 7. And let's look at our parent triangle. And we're going to call it X, X, and X rad 2. So this is, how much is A? 7 rad 2. Okay, so I'm teaching you two things at once. 45, 45, 45. Sorry. 45, 45, 90, and 30, 60, 90. Okay. Oh, one more thing. Notice if you're doing a 30, 60, 90 triangle or a 45, 45, 90 triangle, one of your answers will be a radical. Okay. And the directions will say answers as radicals in simplified form. One of your answers, there's no way to get out of one of them being a radical. Sometimes all 3. That's a really crazy one. Okay. Now we're going to do SOHCAHTOA, which you also did in geometry, and you're going to like SOHCAHTOA better, but it's not going to give you a radical. SOHCAHTOA will only give you decimals or whole numbers. Okay. The sine of an angle is opposite leg over hypotenuse. The cosine of an angle is adjacent over hypotenuse. The tangent of an angle is opposite over adjacent. SOHCAHTOA. Okay, let's take a look at this. Let me clean it up a little bit. Okay, according to SOHCAHTOA, the sine of angle 30. Now remember, these triangles are right triangles. So if they have a 30 and a 90, they are similar and their sides are in proportion. Okay, I don't want to do that. Let's do, oh, sorry. Strike the record. Okay, so we remember that it's 5, 10, and 5 rad 3. what would be the sine of 30 degrees? So let's look at SOHCAHTOA. The sine of an angle is, O stands for what? Opposite. So notice this is always hypotenuse. The side that I'm touching is adjacent. And I throw the eraser, and the one that I throw and hit is opposite. So what is the sine of 30 degrees? Opposite over hypotenuse, which reduces to 1/2. Okay. Now, if I made all of this disappear, when this was 6, the hypotenuse was 12. You could also say sine. Sorry, this is like, there's so much going on up here. Focus on the 6 and the 12. Sine of 30 degrees, if I use the bigger triangle, is 6 over 12, which reduces to 1/2. So no matter what size the triangle, the sine of 30 degrees is always going to be 1/2. And in trig, we actually use decimals. Okay. Tangent of angle C. Step 1, label the hypotenuse. Which one's the hypotenuse? 5. Which one is the adjacent leg? Adjacent is the one I can touch. The 4. Can you see that if I'm standing at C, I can touch the 4? That is the adjacent leg. That makes, now I throw my eraser, and that makes the 3 the opposite leg. Okay, according to SOHCAHTOA, tangent. So it says write the ratio. Now you're going to be very careful. Write the directions. Once I teach you how to solve, you're just going to want to solve everything. But all it says is find the value of the ratio. So tangent of C is opposite leg over adjacent leg, which is 3 over 4. What would you type into a Canvas quiz? 3 over 4. 3/4. Okay, number 9. SOHCAHTOA. Angle A, that's your point of reference. What is the hypotenuse? 35 is the hypotenuse. Adjacent leg, the one you can touch. Adjacent leg. I throw my eraser, hits the opposite wall. According to SOHCAHTOA, sine of angle A is opposite over hypotenuse. So what is the ratio? 28 over 35. I cannot think of a greatest common factor of 28 and 35. So I'm going to use the calculator. 28, ABC, 35, hit the equal sign, the TI 35 will reduce your fractions for you. And we're going to get 4 over 5, right? Or divide by 7. Okay, so know how to use, when you come in to take your test, if you want me to show you how to use the fraction button, then I will show you. Okay. Cosine of X. Oh, well. So X is where our reference point is. 45 is the hypotenuse. 36, X can reach out and touch it. That's adjacent. That makes this opposite. Cosine of X, according to SOHCAHTOA, adjacent over hypotenuse. $36 over 45. 36 ABC 45 is 4/5. Again, was the other one 4/5? Coincidence. That's a coincidence. All right. So the direction said, write the ratio. What if it looked like this? What if it said cosine of angle X, but it didn't give you this value right here? Could you find the value? If you have two sides and you're looking for a third. So if I have two sides and I want to find the third side, I would use what theorem? Pythagorean theorem. A squared plus B squared equals C squared. So there's a possibility you might need to use Pythagorean theorem, find the third side so that you could do what you could write the trig ratio for cosine. Okay. But we're not going to do that. I just wanted to bring that up. Do you have a calculator? Okay. Solve for X. Now, different ways of finding the side of a triangle. You could use Pythagorean theorem. Can we use Pythagorean theorem here? Okay, you would need to have two sides. So no, we can't do Pythagorean theorem. How about 45, 45, 90 triangle? Nope, that's not a 45. How about 30, 60, 90 triangle? Nope. Okay, so our last option is SOHCAHTOA. So step number one, determine which method to use. Can't do Pythagorean theorem, can't do 45, 45, 90, can't do 30, 60, 90. We're going to use SOHCAHTOA. Okay, this right here is my reference. I'm not going to call it reference angle. This is my important angle. Label the hypotenuse. The 20 is touching that side right there. And the 20 throws an eraser. Well, now, when I was in the classroom, normal school, I would actually throw an eraser, hit the back wall. Very cool moment. All my students were completely awake at that moment. Okay, throw the eraser. This is the opposite side. Okay, so we have to choose. Notice nothing over here. Nothing over here. We're not using the adjacent. So I am using opposite and hypotenuse. So which trig function do we use? Okay. So opposite and hypotenuse, sine of 20 degrees is opposite over hypotenuse, 14.1 over x. Okay, sine of 20 degrees. You can do that in the calculator. Make sure your calculator is set to degrees, not radians. Or we can look at a trig table. Guys, I had calculators when I was little. My dad, when he was studying trig, don't do that. When he was studying trig, he used trig tables, and for logarithms, he used a slide rule. Anyway, okay, so I need the sine of 20 degrees. Yeah, it's here somewhere. Sine of 20 degrees. So sine is right here. 20 degrees is right there. Sine of 20 degrees is 2420. Okay, so 2420. Ah. Okay. I don't know. Is it 3420? Is equal to 14.1 over x. Now, on your calculator, okay, so do the sine of 20 degrees on your calculator. Sine of 20 degrees. It's actually 3,4,2,0,2,0,1,4,3. We have approximated, we've rounded that off. So we're introducing a little bit of error. Okay. But I've rounded it off. When you get it from the trig table, it introduces a little bit of error. Okay, cross multiply x times 0.3420 is equal to 14.1 times 1 and divide. X is equal to okay, do we get 41? 41.225. Round your answer to the nearest tenth. X equals 41.2. Okay, so we're going to choose the method, this case, SOHCAHTOA. Write our equation and solve. Notice, can I use 30, 60, 90? Nope. Can I use Pythagorean theorem? Nope. And that 28 actually goes up there. It didn't really fit very well. SOHCAHTOA. Okay, label the hypotenuse, label the adjacent leg, and label the opposite leg. Okay, we have to choose sine, cosine, or tangent. Yep, it looks like I have adjacent and hypotenuse. Adjacent and hypotenuse. Cosine. Cosine of 28 is adjacent over hypotenuse. Okay, now I'm going to show you a trick and you could just cross multiply. I hate it when my x ends up on the bottom. If you're instead of cross multiplying, you can do a flip. Now, notice 1/2 is equal to 3/6, right? If I do a flip, 2/1 is still equal to 6/3. I've changed the value, but the equal sign still holds. So personally, when I do this, I go flip. Okay, I just am so much happier when my x is on top. So how do you isolate your variable? Multiply by 3. Notice I have not replaced cosine of 28 with a decimal yet. You could, or just do it at the end. Okay, with your calculator, you're going to take 3 divided by cosine 28, close the parentheses, equals. X is equal to 3.397. Round to the 10th place. X is equal to 3.4. Okay, now people tend to feel way more comfortable with SOHCAHTOA and they think, oh, forget it. I'm not going to do this. I'm not going to memorize 30, 60, 90. Notice SOHCAHTOA gives you decimals. It will not give you radicals. Okay. Word problem. I wish that would go somewhere else, but Neil sees a rocket at an angle of elevation of 25 degrees. Neil is located 2 miles from the rocket's launch pad. Now, why are we doing what word problems? So that you can see that this math is relevant to your life. Yeah, you may want to calculate this someday and you could use tangent. Actually, there's a thing called a clinometer where you can measure an angle. So when I was in the classroom, I was in a 2-story math building. We used our clinometer and we calculated the height of the math building. So memorable. I thought it was a lot of fun. Okay. Neil sees a rocket at an angle of elevation of 25 degrees. Draw that angle of elevation. Neil is located 2 miles from the rocket's launch pad. How high is the rocket? So where's X go? Okay, so it is the vertical distance. It is the opposite leg. Now, actually, Neil, his eyes are 5 feet above the ground. We're not going to worry about the 5 feet. So why are we not worried about his height, his eyes above the ground? 5 feet, 2 miles. Can you see how the 5 feet's not significant? 2 miles. Okay, so we're not worried about the fact that his eyes are 5 feet above the ground. Okay, I want to find out how high is the rocket? Here's the rocket right here. There we go. Okay, can I use the 30, 60, 90? No. Can I use Pythagorean theorem? No. I'm going to use SOHCAHTOA. Now, in engineering, I believe, not that I've studied engineering, tangent is the most common because you have a horizontal distance and a vertical distance. Do you have the hypotenuse? No. Is there a string attached to the rocket ship? No. A lot of your trig word problems actually use tangent. So adjacent hypotenuse, not using. We have opposite and adjacent. So tangent of 25 degrees is opposite over adjacent. Now we are going to isolate the variable without, and then grab the calculator. Multiply by 2. So x is equal to 2 times tangent 25. 2 times tangent 25, close the parentheses. What do we get? 0.9326, nearest hundredth. 0.93. Notice my picture is not drawn to scale because the opposite leg should be about half of the adjacent leg, which makes sense because this is close to 30 degrees. This is all so interesting. Okay. Hey, there we go. Now, here is an example where we're actually going to have a hypotenuse. Okay, here's a store. A ladder is 10 feet long. It leans against a wall of a store with an angle of 50. How far up the store does the ladder reach? Okay, A, B, or C. Where do I put the 10? Yeah. Yeah, Zoomers, the ladder is 10 feet long. Where do I put the 10? There's the ladder leaning against the store. It makes an angle of 50 degrees with the ground. Okay. How far up the store does the ladder reach? There we go. So here's my angle. Hypotenuse. The hardest part is drawing the picture. Adjacent, opposite. Okay. Doesn't look like we're using adjacent. It looks like we're using opposite and hypotenuse. So what trig function do we use? Yeah, what do you think, Zoomers? Opposite and hypotenuse uses sine, opposite and hypotenuse. So sine of 50 degrees is opposite over hypotenuse. Isolate your variable. I love it when the X is on the top. So X, oh, sorry. Okay, plug that into your calculator. 10 times sine 50, 7.6604, round to the nearest hundredth, 7.66. Okay, so as word problems go, these are not bad, right? You just got to know how to draw the picture and where to put your parts. A skateboard ramp. See, this is super relevant to your life. Makes a 40-degree angle with the ground and has a vertical height of 5. Vertical height of 5. Find the length of the ramp. Adjacent leg, not using. Opposite leg, hypotenuse. Which trig function are we using? Okay, sine of 40 degrees is opposite over hypotenuse. Okay, you guys might not want to do this. You guys might rather cross multiply. Hate it. X is on the bottom. Let's do flip flip. Okay, now how can I isolate my variable? Multiply by 5. Grab your calculator. 5 divided by sine 40. Notice sometimes you're multiplying those two things and sometimes you're dividing. 5 divided by sine 40. $7.778, round to the nearest tenth, 7.8. Okay. Now, sine of some angle is 0.1908. Now, this is the inverse function. Okay, sine of some angle is 1908. So I need to do the inverse to work backwards. So sine inverse of 0.1908. Yeah, I need to do the inverse function. Okay, let's go back and look at that trig table. The sine of some angle is 0.1908. What is the angle? Okay, so sine 1908. There it is. So the measure of angle U is 11 degrees. Okay, measure of angle U is 11 degrees. Now let's do it on the calculator. So you want to do inverse sine. With this calculator, you go second sine. That gives me the inverse. Okay. So, yeah, can you see that it says sine inverse? Okay, that's enough. Okay, sine inverse of 0.19, oops, 1908. You would get measure of angle U is 10.99947, which rounds to 11 degrees. Okay, so that's how you use it with the table. I'm going to let you do number 17 on your own. Now let's go to 18. Okay, find the measure of angle B. I have two sides. Can I use Pythagorean theorem? Okay, I could, but is that going to help me find an angle? Pythagorean theorem is only sides. I can't do 30, 60, 90. I can't do 45, 45, 90. So let's do SOHCAHTOA. So we have opposite, and 9.3 is adjacent or hypotenuse? Hypotenuse. Okay, opposite and hypotenuse is which? Sine, opposite and hypotenuse. Sine, I'm not comfortable with theta. I'm just going to say x is 7 over 9.3. This looks just like the other triangle problems we just did. But here's where it takes a different turn. Okay, notice x is already isolated. At this point, you're going to want to multiply by 9.3. No, you don't multiply by 9.3. Okay, so look, how could we make it just like one of those problems? What do you think my next step is? All right, let's take 7 divided by 9.3 and let's change it to a decimal. So 7 divided by 9.3. Okay, so sine of some angle is 0.75268881. So you can either type it in or you can go second sine, which gives me the inverse, second sine of the answer, second. Okay, so, or you can just type in the number. This is the way I like to do it. And it puts the answer in for me from above. But you can just type in the decimal. 0.7526881 equals. So theta is approximately equal to the nearest 10th, 48.8 degrees. Okay, let's do number 19. Okay, let's label hypotenuse, opposite, adjacent. Okay, which one am I going to use? opposite and adjacent tangent of theta, I don't need x, I'll just use theta, is opposite over adjacent. When I'm finding the angle, what is my next step?
Divide 6 by 8.
Okay, 6 by 8 is 0.75. So tangent of theta is 0.75. So now I'm going to go second tangent, which gives me the inverse of 0.75. Second tangent, 0.75. I always close my parentheses. Theta is approximately equal to 36 to the nearest tenth, 869, approximately equal to 36.9. That's all. Okay, now we are done if you have to go, or does anyone want to stay and look at the practice for campus quiz? Oh, actually, I said we'd go back and do this one. Okay. So am I going to use Pythagorean theorem, 30, 60, 90, 45, 45, 90, or SOHCAHTOA? Let's just check. Oh, the directions say I have to leave my answer as a radical. I can't use SOHCAHTOA because SOHCAHTOA only gives me decimals. Okay, so I have to use 30, 60, 90. Here is my parent triangle. The short leg is x, the hypotenuse is double that, 2x, and the long leg is x rad 3. Oh yeah, I have the short leg. Okay, if the short leg is 4, how much is the hypotenuse? 8. Double. And going back to the short leg, how much is the long leg? Yeah, what do you think, Zoomers? Is it 4 rad 3 or 8 rad 3? Always go back to the short leg, 4 rad 3. Okay, that is all. I thought we were going to go faster and I was going to do some practice for campus quiz, but they're just like these. Okay. Zoomers, are you there? Thank you for coming. Any questions? You're welcome.